Welcome to IDS IT. Let's explore an important topic shaping the future of defense and global security. I'm the founder and director of International Defense Security and Technology, a California-based nonprofit think tank dedicated to research and analysis on global defense, security, and emerging technologies. I also serve as CEO of Interplanix LLC, a New Mexico-based company advancing satellite risk analysis, orbital debris forecasting, and space security frameworks to ensure mission assurance and resilience. Previously, I served in leadership roles at India's Defense Research and Development Organization, DRDO. Most recently as Director of the Systems Analysis, Modeling, Safety, and Quality Cluster at DRDO Headquarters, New Delhi. This channel brings you deep insights into the global security ecosystem, from geopolitics and emerging military technologies to cyber, space, and system-level analysis of tech trends and their interrelationships. Subscribe and join us as we decode the forces shaping the future of global defense and human security.
Today, we are diving into a revolution you may not even see because it's engineered at the nanoscale. Welcome to the world of metamaterials. The artificial substances transforming everything from your smartphone to the battlefield. These aren't your average materials. Built with incredible precision at the micro and nano level, metamaterials manipulate waves, light, sound, radio like nothing found in nature. The result: antennas that bend signals, radar systems that disappear from view, and medical devices that see through the body with unprecedented clarity. Once a lab curiosity, metamaterials are now powering a $2 billion global market, one projected to skyrocket to over $15 billion by 2034. So, what's driving this surge? Let's start with telecommunications. As 5G and soon 6G become the new normal, traditional antennas are struggling to keep up. Enter metamaterial-based antennas. These sleek, flat designs capture signals up to 95% more efficiently and work seamlessly from 350 MHz all the way to 44 GHz. Companies like Kymeta are already installing them in cars, trucks, even boats, eliminating the need for bulky satellite dishes. But the impact doesn't stop there. In defense, metamaterials are being used to reduce radar signatures, enhance jamming resistance, and build stealthier platforms. India's Kanpur is developing metasurface coatings that deflect radar, while US firms like Echodyne are rolling out lightweight radars for drones and aircraft, cutting payload weight by nearly 40%. The aerospace sector is also adopting metamaterials at speed. With over 30,000 new aircraft expected in the next 2 decades, there's a massive demand for lighter, smarter, and more efficient components. From adaptive skins to ultra-efficient satellite systems, metamaterials are helping next-generation aircraft go further and faster while saving fuel and space. Meanwhile, the healthcare industry is finding new hope in these nano-engineered wonders. Metamaterials are enhancing resolution by 30% and enabling compact biosensors that monitor glucose and detect cancer early. With medical tech spending on the rise, these breakthroughs promise more affordable, accurate, and non-invasive diagnostics. And here's the kicker: all of this innovation is accelerating thanks to artificial intelligence. AI is now designing nanostructures up to 100 times faster than traditional methods, unlocking devices like beam steering LiDAR for autonomous vehicles, and metasurface chips for optical AI processors. AI isn't just a user of metamaterials, it's helping create them. From an application point of view, antenna and radar systems led the charge, holding nearly half the market share. And in materials, electromagnetic and terahertz metamaterials are growing fastest, powering secure communications, next-generation imaging, and advanced sensors. Regionally, North America dominates, driven by massive defense investments and tech startups leading the charge. But Asia-Pacific is catching up fast, with billions flowing into 6G research and defense applications. Even Europe, traditionally slower to scale, is carving out niches in acoustic and environmental applications. Of course, challenges remain. Scaling up manufacturing is tough, but new techniques like nano-imprint lithography and roll-to-roll printing are making mass production viable. AI-driven design is reducing costs and shortening development cycles. And with global defense budgets rising and consumer electronics booming, the pressure to innovate has never been higher. Looking ahead, expect metamaterials to become as common as silicon chips. By 2030, they'll likely be in 90% of wireless base stations, embedded in autonomous vehicles, and even cooling your buildings with energy-efficient radiative metasurfaces inspired by Saharan ants. As Dr. David Smith, the creator of the first invisibility cloak, put it, "We are not iterating. We are reinventing wave physics." Metamaterials aren't just a new tool, they're the blueprint for the next technological era.